Welcome back to Weld.com. So today we're going to be doing some modes of metal transfer. To make it even better, we got this new Xyrus camera in color, so you're going to get some crazy cool arc shots. We're going to go through globular, short circuit, and spray. We're going to go through the 3 different modes. We're going to explain some of the advantages, disadvantages, requirements, and limitations of each one as we go through the different processes. And then once we get done, we'll do a cut and etch to kind of show you the penetration profile. Let's get to it. All right, so first we're going to start off with globular. So I have 100% CO2 here. You can do globular with different mixes of CO2 and argon, but we're going to, for this case, we're going to go ahead and use 100% CO2. So let's go ahead and talk about the machine settings. We're going to run 450 inches a minute and 33 volts. Basically what globular does, it creates blobs of molten metal that are going to fall into the puddle. It sounds very similar to short circuit, but like I said before, we're going to get better penetration.
As you can see, you get the little ball droplets coming off of there. Pretty aggressive, and you get excessive spatter with it. That's why, you know, if you run globular, you can anticipate high cleanup costs. Cleanup's not an issue. You don't have to worry about it. Save your money on gas. Like I said before, it's a very aggressive process. There's a lot of spatter associated with it. You're going to spend more time in cleanup. It's going to cost a little bit more. Once we get into the other process, you'll see it starts to get cleaner, right? So when we get into short circuit, it's going to be a little bit cleaner. There is some spatter associated with it, but it's a lot easier to clean up. We're running 12 inches a minute, about a 2-minute weld. Once we get into spray, there's virtually no spatter. Electrode efficiency with this is about 85 to 89%. Okay, you're going to lose a lot more of your electrode to the spatter. Once we get into different processes, you start gaining additional electrode efficiency. Alright, so I'm going to stop talking. I want you guys to pay attention, watch exactly what's happening in this puddle formation, and listen to exactly what it sounds like. So that right there is globular. Let's go ahead and move into short circuit.
Okay, so as you can see, we got a pretty decent bead overall. We've got a good convex profile, good wetting it at the toes. But again, there's that spatter, you know, and depending on, you know, we're using a MIG tractor right now. So human error is going to play into effect, contact tip to work distance, travel speed. You know, we maintain a constant 12 inches per minute. You know, you can get a lot more spatter when you're doing it by hand. So we're going to go ahead and move into short circuit. Some of the benefits of short circuit is I can take that out of position, whereas with globular, I'm restricted to the flat and horizontal positions only. With short circuit, I can get out of position, so flat, vertical, horizontal, overhead, whatever position you want to get into. The limitations of that are you should not weld anything greater than 5/16 in thickness. So we start getting into 3/8 plate, things of that nature. That's not the process for you. That's not the mode of transfer. You want to go back down to a globular, or you want to get into a spray transfer. Spray has some limitations too. We're going to get into that when we cover spray. But right now I'm going to go ahead, switch the tank over to 75/25, readjust my settings, and then we're going to run some short circuit for you. So we're going to go ahead and run a 75/25 mix. That's 75% argon, 25% CO2. I'm running about 20 CFH. Let's go ahead and talk about the machine settings. About 19 volts, and wire feed's about 350. Damn Loch Ness monster. We're running 350 inches a minute on the wire feed speed, 19 volts. We're all set up on the tractor. Let's go ahead and run some short circuit.
What you're noticing here is actual short circuit. Okay, that wire is hitting the puddle and creating a dead short in the circuit 20 to 200 times a second. That's why you get that nice loud crackling sound. You still have a little bit of spatter associated with it, but you know what you can change that out with is the fact that you can take this out of position. Once again, it's great for anything 5/16 or less, any position. But once you start getting into 3/8 or thicker plate, you want to start changing the mode of transfer to a spray or a pulse spray if you have to get out of position. I'm going to hold a tight contact tip to work distance on here. Typically recommended 3/8 to a half an inch, no more. This stuff runs pretty good. I mean, it's a very, very common process. Most industries are, you know, this is what they use for a lot of construction. Still running 12 inches a minute, so it'll take us about 2 minutes to get through this entire 24-inch piece. Listen to that crackle sound. That's that bacon sound that everybody talks about. stuff's great for open root on pipe because you don't get excessive penetration with it. You get really good bead appearance, so if you're worried about aesthetics, this is a process you want to consider. And what makes this happen is that addition of that 75% argon. There are other concentrations you can run and still achieve short circuit, but 75-25 is pretty good for guaranteed success, and it's relatively cost effective.
All right, so now we're going to get into a spray transfer. With spray transfer, I need to run 82% argon or higher. So right here I have a bottle of 90-10. It's 90% argon, 10% CO2. So 82% or higher. So just remember that, like 85-15 is a good blend. There's a bunch of them out there. You can get into a tri-mix that has oxygen. This one's just 2. We should be able to get it. So we'll go over here and you'll be able to see exactly what happens in the arc and the puddle. It's pretty cool. It's one of my favorite processes.
All right, so you can see that spray transfer in there. It's probably one of my favorite processes to run. There should be very little crackling. I got to increase that contact tip to work distance a little bit. You get that nice hiss. Although it costs a little bit more, production goes up, right? You're putting more metal down, putting it down a lot faster. We've increased 8 inches per minute just on travel speed alone. Not to mention the deposition rates we're going to, or I'm sorry, the penetration profile we're going to get out of this. Get a much deeper penetration profile than we did with our 75-25 or short circuit welding. You can actually see how this stuff comes off in fine little droplets. It's like running a water hose in there.
So that was spray transfer. As you can tell, as we start from globular, we get into short circuit, into spray, we get less and less spatter. So we get a lot more electrode efficiency the higher up we go. That's pretty much modes of metal transfer. We'll do a cut and etch. You'll be able to see the weld nugget in there, the profile, and what the different types of gases actually have on that. So the more we increase our argon, the better off we're going to be. But you don't want to run 100% argon when we're doing steel. Okay, you want to have some composition in there of either CO2 or oxygen or a blend of the two, because with 100% argon, you get like a finger-like profile of penetration. It's kind of deep, but it's narrow. Once you start adding CO2 to that, you get a much deeper and wider depth of penetration. All right, so for everybody that's been asking, what's the difference between short circuit and spray and globular? Hopefully that answers your questions. You're a lot more familiar with it now. You can actually see it in action. We're gonna go ahead, chop these up, do a cut and etch. Okay, so as you can see, we got better depth of fusion than we did with our short circuit. We're punched into the vertical wall pretty good, as well as the horizontal, and pretty good root profile. So remember, CO2, you're gonna have a much deeper, wider penetration profile. Limitations with this, with globular, is I can't take it out of position, and there's usually a lot of post-weld cleanup associated with it due to the amount of spatter. All right, so short circuit, very, very little penetration. Didn't penetrate much into the bottom part, neither on nor on the vertical leg, and really didn't catch that root, the equal leg length. So it wasn't the angle. It's just this process. That's 5/16. So we're kind of hitting the limitations of short circuit. Bead appearance is pretty good, so looks can be deceiving. You got to check that penetration profile. That's why short circuit is not really recommended. It's not pre-qualified. Let's go ahead and move into the spray. All right, so this is spray, and clearly we're driving in a lot deeper on this one. So the root, we got full penetration in the root. The addition of that argon, that CO2, the wire feed, or the wire feed speed, all those come into play, the higher amperage. But we're operate within the limitations of that wire, and this is the results we're getting. So you can kind of see the big differences between these modes of metal transfer. All right, guys, so there you have it. You have globular, short circuit, spray. You can see the difference in penetration and the profile, the depth of fusion, all that stuff's in there. But don't take my word for it. Try this out at your house, right? Do some additional research on the internet. There's a bunch of stuff available. You guys are watching YouTube. Click on over, open up your web browser, and look up the different modes of metal transfer and the reasons why we use one over the other, right? I'm just kind of giving you an introductory. We had some questions on this, so we thought we'd explain it, okay? You can see the limitations, advantages, and disadvantages of each one. So I hope you guys learned something. Really appreciate you guys watching. We had a lot of fun making the video. Till next time, make every well better than your last.
Pulse spray transfer sprays a stream of tiny molten droplets across the arc from the electrode to the base metal. But unlike spray transfer, the stream is not continuous. The power source rapidly pulses the welding output between high peak currents that cause the transfer to spray and a lower background current that maintains the arc but does not allow any metal transfer to occur. The pulsing of the current produces a buzzing sound,